So just to repeat again, now that we're recording, this is for my CS and AI education class, as well as just to help you guys out. Broadly speaking, it's on pseudocode, but more specifically, we'll kind of narrow down that focus afterwards to kind of how does this apply to Sudoku as a group project and just as a general project and how we can apply that to classes going forward. And so obviously the first question is, what is pseudocode, right? And so obviously the majority of the code that we do in this class is actual Python code. The thing is, very often, sometimes you'll do a preliminary step before that, which we usually call pseudocoding. And this is going to come up, especially when you get into wanting an internship at a job. A lot of the times, instead of asking for actual code, they'll ask for pseudocode. And so if you want to think about it, it is quote unquote code, except it doesn't have any of the concrete requirements that Python, Java, C++, etc. have. And so in that sense, there are no specific rules, but the general idea is kind of outline everything. And so the biggest part about this is it helps you cover the logic of your code, right? Making sure that the logic is sound before you attempt to code it, and then you have more issues, right? You have implementation issues, you have syntax issues, so on and so forth. And so obviously, the less things you have to think about at one time, probably the better, right? So thinking back to Blackjack, that was the first project that we did in this class. And so the beginning of Blackjack, it's just like, okay, what do I need for this game to function? The first idea is probably, okay, I need some kind of loop, right? So as you can see at the bottom, I just wrote this up in a couple minutes, right? So while the game is not done, how are we going to check the game is not done? We'll figure that out later, right? But then maybe we need another loop per game, right? Because otherwise, how are we going to track each game? We then get a card value, and then we know that we need to do something else with that card value, right? We need to change it from, say, a king, queen, a jack, and turn those into tens, right? And then we need some kind of user input in the menu. And so here I listed it as a switch. Obviously, the current version of Python used for Zybooks does not support switches, so you can't actually do that. But this is the general idea of it. So why pseudocode? We kind of already touched on that. The biggest thing is it helps you basically kind of speed run the coding aspect of it and make sure that you're not missing anything, right? It's like for your binary code or your binary decoder, right? First, you need to make sure that you know how to take binary and turn that into decimal before you can actually write that code. And so you might iterate through a couple of steps. And then if you walk back through that, right, think like your exam questions where it's just like, what is the output of this? It's like, if you follow that, you might notice that you have some issues with implementation, right? Either it's like, oh, I need to start indexing at 1 because 2 to the first power is where I want to start this. Or maybe I need to start at 2 to the 0, so on and so forth. And so it's a descriptor in the sense that it is not actually Python code, but it is easier to read than Python code in theory, at least as it pertains to you. And then from there, it makes it a lot easier because maybe you've started your project and then about 2 hours in, you take a nice little break, you take a nap, then you come back and then you look at your code and you're like, I have no idea at all what I was doing here. I don't know what the goal of this method was. I just have a loop that is currently throwing an index out of bounds error. I have no idea what's going on. So part of the goal of pseudocode is you have that skeleton of functionality prior to it so that that doesn't happen, right? And so obviously, as this pertains to you, this, because I think this blocks part of the text. Regarding reading your documents, this was a very big topic when it comes to office hours during project 2 for image RLE, where a lot of people came in asking like, I don't know what decode RLA means. I don't know what encode RLA means. I don't get why we have to make a count runs function. And for the most part, all of those parts of the project are scaffolding in the sense of those required functions are supposed to cooperate with each other. So you have to do less coding, right? Like some of you might have realized at some point, that the count runs function is useful when you're encoding the RLE into an array, because one of the values that you need to figure out is how long does my end array need to be? And the answer would be 2 times the count runs of whatever the pass in of that is. So in that sense, that scaffolding had a purpose. It's just when you start it and you just start coding, sometimes you kind of miss the general goal of it. You don't really know what you're trying to do. You just know, I have an example input, I have an example output. Let me try and figure out how to get there, right? So what makes this useful to Sudoku? Sudoku, for this class at least, will probably be the largest project that you'll have to work on. It is also a group project. So everyone kind of needs to be on the same page, at least to some degree or another. And so if you've looked at the PDF, there are quite a few different methods required. A lot of them, probably at a first glance, you'll figure out, yeah, that makes sense. That's why we need this. But a lot of the methods also have some kind of functionality relating to each other, in the sense that, oh, if you implement this function first, it will most likely be easier to do this other function. Or on the other side, the output of this function is what's required for me to get to use this method. And so if this functionality is not correct, we need to check why it doesn't work, right? And so basically touching on that, it's making sure that you are actually hitting what the project specifications ask for, because you cannot, unfortunately, shove this one through Zybooks for every single possible point and be like, okay, it works at the very end of it. You have to visually inspect a couple of things. You have to just kind of make sure everything works. And then splitting that into a group, of course, makes it a little harder. So the idea is pseudocode helps you break that down, make sure that you are all on the same page, that kind of deal. So for a small little example, given the prompt of function to get the average of 2 numbers, right? Say we have one number is 5, one number is 10, right? We can then obviously summation them, divide them, and print them. This should be pretty similar to, I believe, your lab 2, where you start working on a 4-function calculator, right? And so if you think about it in terms of pseudocode, it's relatively straightforward, right? You're like, okay, I need to take 2 inputs. From there, I need to see whether or not they want to average it, which at least for this case, of course they do, because that's the ask of the function. And then how do you do averaging? It's like, well, you add them and you divide them. So obviously that's a very, very small toy problem version of it, right? And so obviously you can see here, this is a little less of the formalized logic or formalized code structure, right? You just say number 1 is 5, number 2 is 10, so on and so forth. So going back to project 2, I would like you guys to take a couple minutes and just think about this section. If you want to write something, by all means, I'll give it about 2-3 minutes, and then I'll talk a little bit more about the section. All right. Hopefully that was enough time for you guys to at least attempt it if you wanted to. Would anyone like to either speak on it or type about it? If not, no big deal. If so, I am more than happy to give you feedback regarding how I perceive your pseudocode. I know it's a little intimidating though. All right. I'll consider it as there are no willing victims, volunteers. So given this, we all have probably already done this project. So I'll be a little bit more brief about it. But so obviously the core of it is that snippet at the top, right? Of the difference between flat unencoded data and run length encoded data, right? And so we know that we need to get from one end to the other and probably back. But obviously, that's one of the big things where maybe we don't know how to do that. And then obviously there's some functions at the bottom. I already kind of talked about this, but so we can, here, let me share screen differently so that you can see the entire screen. So say we take a notepad. So if we want to think about flat unencoded data, right? So we take an array. We count the number of times a given digit repeats itself. Then we store two values. One is the run count, right? Run length, and then the digit value. So from there, is a pseudocode, kind of, but at the same time, not really. So we can take this a step further and write something closer to code, right? This is closer to an outline right now. And so if we think about it as an array, so probably like for I in range of length of past an array, we now need to iterate across it. So let's see if current digit is equivalent to next digit. Because remember, this doesn't need to be actual Python code. I wrote the for loop as a Python loop because that's what I'm used to. But you could have just said for I across the array if you want, right? But this is technically closer, so why bother? So if the current digit is the next digit, probably add 1 to current count. And now we can think about, should this count start at 0 or 1? When do we need to reset it? Right? And then so from there, we've handled one case where if the current digit is equal to the next digit, but what about otherwise? So else, so we can be like, this means it's not the same digit next. And so if that's incorrect, then it's like, okay, what do I need to do? So if we look back here, we need to store the two values if that's the case. So we'd probably be like store length of current count. And then the other thing would be store current digit. So now the question comes, are we done with this? Yes or no? Does this address the functionality that we wanted of going from flat unencoded data to run length encoded data, broadly speaking? Yes, no, maybe so. What do you guys think? No opinions on that? So given the pseudocode here, right, this section, does this basically broadly describe how we are supposed to go from raw or flat unencoded data to run length encoded data? Obviously, this isn't in Python code, but does this generally address the function? Well, so hopefully the answer is yes, even if you guys don't want to. Oh, there we go. His response is, I believe so. Only thing I would consider regarding this with respect to the project is the run being over 15. Other than that, yes, which is a perfectly valid complaint, or comment rather, not really a complaint. And so maybe during implementation, you need to have something like make sure count doesn't pass 15. And so as you can kind of see, in like 2 minutes, we have outlined at least the ideas of what's here. And so obviously from there, we have a general idea of what we're supposed to do. And so looking at these two functions at the bottom, it makes a lot more sense why in theory, right? Because if we need to store this run length encoded data, and we start thinking about the nitty gritties, I was like, okay, I need to make a list of this length. Well, it's number of counts, or sorry, number of runs times 2. So then we could get something like initialize list using count runs times 2. And then encode RLE, right? Assuming we're utilizing these other functions, this section becomes easier to get the yield list section. So assuming you did some pseudocode of your own, is there anything particularly useful that you derived from this example? Does your pseudocode have something that you think is more useful or stuff that you think that I could have improved on from there? So pseudocode is not a hard science. There is no one correct pseudocode to rule them all. It's mostly about what are you actually going to write and is that useful to you? Right. So now we'll take a look at Sudoku. Let me go pull up the PDF quick. It's here. Right. And so if we look here, obviously, this is the Sudoku page. And there's quite a bit to take in here, right? So obviously the first part of dealing with Sudoku is figuring out, okay, what parts of this do I actually need? Which parts of this do I not need, right? So you have a tutorial video, but I don't know what I'm trying to do right now. So maybe the tutorial video is not going to tell me much. So we have a GitHub Classroom link. You watch a video, so on and so forth. So we still haven't really gotten into what do I need to do with this project. So we finally get to it, right? So it's a 9x9 grid, partially filled with single digit numbers. And then we have some rules, right? And so hopefully you've done Sudoku before, you understand generally what Sudoku is and you don't need to learn for this. But in the case that you don't know what Sudoku is at all, I would recommend that you just pull up a game of Sudoku and play it a little bit. Because it's very hard to code something that you don't understand. Because code is just breaking down your understanding of it into line by line by line implementation. So then we have some UI requirements, right? We have an easy, medium, hard. We have an in progress screen. We have some other requirements. So obviously, the first thing is, how are we doing this in a non-terminal setting, right? And so that would be through Pygame. But we probably need to do the back end before we can do the front part of it, right? So if we look at this section, we'll notice that they require a following set of classes. So we have a Sudoku generator, we have a cell, we have a board, and then we have a main, right? So if we want to kind of think about that, we have a Sudoku generator, a cell, a board, and main. So to kind of skeleton out this code, we can be like, okay, which functions need to be where and how do they relate to each other, right? So if we read further, Sudoku generation involves a process known as backtracking, which is beyond the scope of this class, which means, okay, we don't need to implement that. And so given that, we can note backtracking added here. No need to do it ourselves. True. Let me fully share my screen then. There you go. Now you should be able to see it. But basically, this is just kind of breaking down what it is that you need to do. So that's part of it. And so if we go back to Sudoku generator, we have an init. We'll note that we have some kind of variable row length. And we might need to also have a 9, probably for the other section, right? Because it's a 9 by 9. Right. So we expect probably column like this 9. Is that for sure? No, not for sure, but well, it's a pretty good guess, right? Let's see. We have a removed cells could vary depending on the difficulty level chosen, right? So we notice we'll probably need some kind of difficulty. And then we'll need some kind of tracker for removed cells. And so the context of what is a removed cell? Well, if we have a Sudoku screen like so, it probably generates them all and then removes a certain number of them first. So the removed cells might be the number determined by a difficulty. It's also, if we look through here, remove cells. It says here, this method removes the appropriate number of cells from the board. It does so by randomly generating row column coordinates, which implies that, of course, we need a row and a column, which kind of parallels how we were working on Connect 4 on a previous lab. And then as you can see here, it sets the value to 0. And you cannot remove the same cell multiple times. Some other stuff that we can look at. Get board returns a 2D Python list of numbers, which represents the board. So we probably have a board variable, which is a 2D list. Right, and so we could continue going through this for every single section of this, and then we'd probably get a dumbed down version of the lab document, which in theory will help you with comprehension regarding it. But for you guys, choose a function that you'd like me to go over, anything on here. And we'll at least attempt a pseudocode of it. Valid in box. All right, so let's look at this one. So first of all, valid in box is within the Sudoku generator. And so the Sudoku generator generates a Sudoku, the puzzle as well in this situation. Okay. So we at least have some context. Root. Valid in box. So here we go. Valid in box. So first of all, it returns a Boolean value. So we have inputs and outputs. This is how I personally like to do it. Usually I'll just comment at the very top. It's like, okay, what are my inputs and what are my outputs? So I have row start column start, and then num. Our output is true or false. So the first question is, what does true and false represent here? And so it says determines if num is contained in the 3x3 box from row start, column start, to row start plus 2, column start plus 2. So this says, is num contained? Okay. So probably the easiest way to think about this is a little drawing. So say we had a little going to have to excuse my poor drawing skills. So something like this. So this would be a 3x3. And so if we think about row start and column start, well, so these would be columns. So say this would be 0, 1, 2, 0, 1, 2. And so keep in mind, this order might not necessarily be correct. It might be 2, 1, 0 for the columns or for the rows, right? We don't know, but let's not sweat the details right now. So if we think about, if we take row start to row start plus 2, that basically means for this entire section, which is of like 3. And then you have column start of plus 2. So 0 plus 2 is 3. So checking for whether a number is contained in it, right? So that means basically in some way we need to iterate across all 9 of these to check if there's a value, right? And so where the row start and column start comes from is a different function. So let's not worry too much about that one. So thinking about this, it's like, what do we need to do? Iterate across the 9 indices of, if we say rows are I, columns are J, we have I to I plus 2 inclusive, and J from J to J plus 2 inclusive. And so since we've done some kind of 2D loop iterations on Connect 4, we probably know that this is going to look like a nested for loop, right? So probably something like for I in range of length of I plus 2. But then this like, does this actually do what we need it to do? Maybe not, right? Because if we consider this, say I is 6, right? Length of 6, oh, sorry, it should just be range. I plus 2. So I plus 2 from 6 would be 8. Range of 8 would mean that we go 0, 1, 2, 3, 4, 5, 6, 7, so on and so forth, which is probably not quite the functionality that we want. So some other ways we could think about it is maybe we don't want to do a for loop, right? Can we just access each of these 9 indices? Technically, we could do something like array at I, j, array at I plus 1, j, array at I plus 2, j. And then we can do this again for j plus 1 and j plus 2. Is this a good solution? Probably not. This is probably more work than actually figuring out the logic of your loop, right? But maybe this works better for you. And then we could literally just be like, okay, is num equivalent to this? ... And so, is this a good solution? Probably not. But does this solution work? Maybe. Let's double check. So we get a row start, a column start. And so that would be our I and our J in this case. And then we have num. And then we're checking if true and false or sorry, true or false, with true or false indicating whether or not num is contained in any of these spots. So does this implementation technically answer the question? Yes. So obviously the more elegant solution is you figure out the for loop before it, right? You probably start your conditional and then have an end conditional for I plus 2, or maybe it's I plus 3. Perhaps a while I is less than, like say row start plus 2 or 3, right? Maybe it's less than or equal to, right? And then you could do something like I plus plus, such that I initially equals row start. And then maybe we have the nested for loop. So while j is less than or equal to column start plus 2. Maybe those conditionals work, maybe they don't. We can test this by just kind of walking through our own code on a small scale. But otherwise, does that answer the question of how would we do pseudocode for valid inbox? Yes, no, maybe so. Any other questions regarding this? Let's see, what happens if row start is 8, for example? So that's a great question, right? Here, let's go to share screen again. So if our Sudoku is a 9 by 9, right? So I'll just do that here where we just do that. I'm going to add some spacing just for visual clarity, right? So this should be our Sudoku. Now, if assuming that we are counting like this, should 8 be a correct value? Is 8 considered the start, or should 6 be considered the start? So this is a question depending on your implementation of row start, right? Column start. So assuming that we start from the lowest value, I would assume that 0 is a valid starting point. So we'll just replace that. 3 is a valid starting point, and 6 is a valid starting point. So given that, if we assume that all of our Sudokus are 9 by 9, maybe that means we need some kind of input validation, right? So if that's the case, it's like if we're checking valid inbox, the first thing we might need to do is check if row start is 0, 3, or 6. Check if column start is 0, 3, or 6, right? The alternative is maybe you have some different functionality, or it's like if row start is, what is it, 2, 5, or 8, you'd now have to iterate backwards, right? So on and so forth. Let's see, how come you had to make I equals row start? Can you not just use row start? Well, you technically could, right? Assuming, say, row start starts at 0, you could take row start, and then you could add 1 to that, and then you could add 1 to it again. I, J, K, and so forth are usually used as indexing variables, right? Just to make it a little easier to track them. Do you necessarily need to? No, but maybe it stops making sense when you have check if row start plus 2 compared to row start plus 3. It's like, wait a minute, what am I trying to do here, right? Because in some way you need a variable that tracks your current loop iteration. So maybe you have like row start plus I is less than or equal to row start plus 2, which could be a conditional. It is valid. But is this easier to read and easier to not get yourself lost in compared to just I is less than or equal to row start plus 2? Let's see. This is related more to the project in general, but what is replit? Are we supposed to use that instead of PyCharm? Well, so the glories of the major is you can always just Google stuff like that. So it's like replit. Collaborative browser-based IDE. And then if we think about what is PyCharm, we'll notice it's also an IDE, right? And so the difference with replit is you'll notice it says collaborative, right? And so basically the idea of replit is such that you can work on the same project with other people collaboratively, whereas PyCharm is an individual IDE. Hope that answers that question. But yeah, so that's just the general idea of how we would get started with pseudocode as opposed to starting with just straight coding, because that helps answer a lot of the questions. And so with that out of the way, that is the primary section of the actual workshop done. I will stay on for a couple more minutes to answer just questions about Sudoku. If you guys would so kindly, please fill out this form. That helps me do my class, and that's also part of the reason why for the next couple hours or so, I'll be taking questions on Sudoku. Sorry, not hours, minutes. I'm a liar. So do I mind leaving the notepad up on these? Nope. Here, I can paste this into Zoom chat, please. So in Zoom chat, you'll have a notepad text. Can I do is valid? I mean, we can look at it, sure. Because the glory of pseudocode is it won't take nearly as long as actually writing out the code. And obviously, writing out the code is not very academically honest of me, and not a full view. How do you update the value of a single cell on the board? Well, that depends on your implementation, of course, but under the assumption that we're dealing with a 2D array, right? So if we think about these as all the values stored in it, right? Maybe we can assume that it is an int list, 2D int list, right? So say we want to change this value, let's see here. Well, assuming that this is index 0, maybe we want to do 0, 3 of bar list, right? Equals, say, 9. Right, maybe that's how you update it. Of course, this depends on how you implemented cell and board behavior. Let's see, going into, let's see, your question was on is valid. Is valid. So is valid, you pass in a row, column, and number. Returns if it is valid to enter the number at row, column in the board. This is done by checking the appropriate row, column, and box. So if we want to think about that, this is, we kind of need a little bit more understanding of Sudoku, which is why the first thing I mentioned was, let's make sure that we understand how Sudoku plays, right? So basically, that's asking, can you insert, say, a 3 here? That basically means in this set of both row and column, is there already a 3? The answer is no, then the answer is yes. Consequently, the answer is yes, you can insert it. Then obviously you'd return true. otherwise false, right? So if we want to think about that, say we had like 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then say 1, 3, 6. And so if we want to insert a 7 here, we need to check if it's valid, right? So we'll put an empty bracket there. So the first thing we'd probably do is iterate across this left side. Or is this a row or column? Most likely it's a row, right? Because it's length. So in some way, we'd iterate across row and then check if num matches any of them, right? So we probably need some kind of Boolean value of like found a match, right? And then we would start it at false. And so if num matches any of those values, it'll probably go found match equals true. And then we do the same thing for iterate across column as well. And then so from there, what does found match equals true? So if we double check again, what does is valid represent? Are you allowed to enter that num? So if we found the number already, say we found 3 already, are we allowed to insert it at this bracket? No, because of the rules of Sudoku, we're only allowed to have a number once in every single row and column. So if found match is true, it's true, you probably need to return false. And then else would probably be returned true. Does that make sense? Any other questions for me? If there aren't any other questions, I'll end it here. Once again, I would greatly appreciate it if you fill out that form. It helps me have feedback for my class, and obviously it's the incentive for you guys to have this occasion. So okay, can I go over cell draw? Let's go look at it. Cell draw. Are you referring to the draw function within cell? Okay. So if we look at this, first we need to make sure we understand what cell is. And so it says this class represents a single cell in the Sudoku board. There are 81 cells on a board. So if we think about that in the context of this, any cell is just one of these numerical values, but probably represented a slight bit different. So we have a constructor where it says which row it is, which column it is, a screen variable, and a value. So if we're thinking about Sudoku in just this context, well, I think we can figure out what value, row, and column are. Because column and row would be just what we index it by, and then value would be whatever current value it has. Now, what about screen? Screen might relate to the fact that we actually have to display this in some way that is not just this 2D list. So we'll have to think about that a little later. But so then we have draw, which is called on self, which means no other variables are passed in. But because we looked at the constructor, we know that there are a couple of values that we can work with, right? So it says draw the cell along with the value inside it.
I can't see
what
you're writing.
What was that?
Can't see what you're writing.
Oh, sorry. I mean, I haven't written anything, but basically this spot, for example, would have a corresponding row, column, and value. And then screen we'll have to figure out later because we don't currently know what that is. And then it says draws this cell along with the value inside it. We'll notice there are two different values for set sketched value and set cell value. So those are probably two different values. So if the cell has a non-zero value, that value is displayed. Otherwise, no value is displayed in the cell. Cell is outlined red if it is currently selected. Also, that's a couple different things that we need to think about. So this is valid. Go over here. Draw of cell relative to cell. So it says draw the cell, which we don't know exactly what this does. So it's probably a Pygames kind of thing. If this cell has a non-zero value, so if value, and then maybe we need to figure out whether or not this is cell value, sketched value, or set value initialize. Is this the same thing? Right, because we don't know that right now. So this would be not equal to 0. And then display the value. Well, draw value. How do I do this? So that's probably something else we need to figure out, right? And so maybe we need to look into the Pygames or some kind of thing that talks about how we're supposed to draw this function, right? And so maybe if we look up here, you'll say something about visuals for your game or Pygames. So we'll figure that out there. Otherwise, no value is displayed in the cell. So else no value drawn. And then we have this other random conditional where it says the cell is outlined red if it is currently selected. So that means we probably also need a variable for whether cell is selected. But at least in this context, we just need to see if selected, red border, else, what do we do here? Probably just leave it as default. Right. And in theory, that's it. Obviously, there's a lot of implementation steps missing here because we don't have the whole story. But obviously, because we're kind of bouncing around instead of doing all these methods sequentially, at the very least, we have an idea of, okay, there's a method that we're missing. We need to figure out our implementation of init first before we can do this. And so we start seeing the whole picture of this method needs other methods before we work on this one. So let's figure out what other ones we need. Make sense? Let's see. Why does the board init method only have row length as an argument and not also column length? So if we look at board init has both width and height. So I'm not sure what you mean by whether or not the init has a row length and a column length. In theory, width is one of those and height is the other one. No, most likely it's going to be 99. All right. I will take probably 2 questions. And then I have to go for my next class. So under Sudoku generator.py. Let's see. Well, the initialization for this. Okay, so row length. You notice that for this project, row length is always 9. It's basically the same thing that was mentioned earlier, how Sudoku is traditionally a 9 by 9. So It's the same length either way. Any other questions? All right.